Okay, in this video I'll be going through some matrix multiplication bits and pieces, and hopefully you should be able to get started on your exercises. Alright, so matrix multiplication, or finding the product of two matrices or more, there's some key rules that if you have under your belt, you can actually work out a lot of multiple choice questions in an exam just by knowing these two little tricks, because you can quickly eliminate incorrect answers from either not being able to, knowing that you can't multiply it, or knowing that the product size isn't correct. What I mean by that is, first of all, you need to know the order of a matrix. So remember that the order of a matrix is the number of rows times the number of columns. For example, if I have this one here, it's a 2 by 2, right? Whereas this guy is a 3 by 2, or 3 by 2, right? So when we were adding and subtracting matrices, your order had to be exactly the same. This is not the same in multiplications. There's a few little rules that you need to consider. Rule 1, the condition for matrix multiplication to be defined. So there is a rule to say whether two matrices can be multiplied together. So, for example, if I have a a 2 by 3 and a 3 by 3, maybe this is A and this is B, can I multiply A times B? So if the number of columns in your first matrix is equal to the number of rows in your second matrix, they can be multiplied. All right? So how to quickly do this in an exam? Find your order of your both matrices. So I've got a 2 by 3 and I've got a 3 by 3, and I'm multiplying A times B. So these two numbers should be the same for me to be able to multiply these two. However, in the exam or your SAC, if it says, why are these two matrices, why is their product defined? Please don't say that the two middle numbers are the same. That is not correct. You have to say so remember, this is rows by column, rows by column. So the number of columns in the first matrix is equal to the number of rows in the second matrix. Therefore, the product is defined. So that's the first rule. The second rule is determining the order of the product. So if I use the same example where I've got a 2 by 3 by a 3 by 3, I know that this product is defined. I know it exists because my number of columns in my first matrix matches the number of rows in my second matrix, right? Now the product is found from these numbers here. So it's the number of, so the product is given by the number of rows in the first matrix times the number of columns in the second matrix. Okay? So that is how you get your product order, and to also see if a product is defined. Again, don't say that the outside numbers or I know the product order because of the outside numbers, or don't say the product is defined because of the inside numbers. That's not correct. That tells us nothing. You have to talk about your number of rows and columns of your first and second matrix. All right? So that's the first step. Now, multiplying. What I want you to do is, if you want to have a go at this with me, get out a few different colors and you can see what I'm doing. And we'll do a few examples and you'll get it by the end. You should have done a little bit of this last year and hopefully it will come back to you. All right, so we've got the product AB. So that means I'm timesing A times B. So A, let's check if it's possible. A is a 1 by 3 and B is a 3 by 1. So are we able to multiply these two in this order? Now remember also, A times B is not the same as B times A. B times A might not even be possible. You've got to check, right? So they are not going to be the same most of the time. Just keep that in the back of your minds. Okay, so is this possible? So quickly, I can see that the number of columns in the first matrix is equal to the number of rows in the second matrix. So therefore, this product is possible. And I'm going to end up with a 1 by 1. All right, so let's have a look at this. 1, 3, 2 times 2, 4, 1. So what you're doing is you're going to multiply every row by every column. So every row in the first matrix by every column in the second matrix. And if there's multiple, you add the elements or the parts together. All right, this one's really simple because we're only going to get one element at the end. So let's have a look. So the first step here, I'm just going to start that. I'm going to go 1 times 2. So 1 times 2. Now, because I haven't finished my row, I know that I haven't finished the element. So that means I'm still adding to that. So that means that as I go further, I'm going to be adding, right? So now my second part is a 3 by 4, right? And I still haven't finished my first row. So I know that I am going to be still adding on. So plus 2 by 1, 2 by 1. Now, I've run out of my row, right? And I have no more columns to continue with. So that means I've only got one element. And then if I equate all of this, so I've got 1 times 2 is 2, plus 3 times 4 is 12, plus 2 times 1 is 2. So I've got, what's that, 14, 16. So I've got 16 is my answer. And if I check, it's a 1 by 1, perfect. Now, of course, you can do this in your calculator as well, but you will, there will be some instances where you have the answer and you have to work backwards. So you do need to know how the multiplication works. Let's try a more difficult one. Remember, rows by columns. So we're going A times B. So we've got a 2 times 2 times a 2 times 1. We are able to do this multiplication because the number of columns in the first matrix matches or is equal to the number of rows in the second matrix. And I'm going to end up with a 2 by 1 as my final order. All right, let's have a look at this one. Okay, so first step, I'm going to do exactly the same as what I did in the other one. So I'm going to go 1 times 2. So the first element in my first row times the first element in my first column of the second one. So I've got 1 times 2. Now, because I haven't finished this row, right, I know that I'm going to be adding to that element. So 0, so my second column in my first row, my second one along in my first row, times the second one along or down in my column. So 0 times 3. Right? Now, because I've run out of row here, I know that I'm going to go to a different element, right? So I've run out of rows. I've finished my row with my first column in my second matrix. So I would repeat this row for my second column if there was one, but there isn't. So I know that I've exhausted this row with every column of my second matrix. Once I've done that, I know I'm going to the next row in my solution matrix. All right, so I'm going to do the same process. So this time I've got 2 times 2. So 2 times 2. I'm not finished this row, so I know I'm still adding to that element. So, and then I've got 3 times 3. 3 times 3. I've run out of row for that column. I would go on to the next column in the second matrix if there was one. There isn't, so I know that I am finished. And then if I work that out, so I've got 1 times 2 is 2 plus 0. And then I've got 4 plus 9, which equals 2 and 13. Okay, let's have a go at a 2 by 2 by 2 by 2. Let me get the right colour. All right. So you're going to need a few colours here, so at least 4. Right, so remember we go row, row by column. Then we keep going. We have to finish the row with every column available in the second matrix. All right, so let's have a look. All right, so 1 times 4, 1 times 4. Now, because I haven't finished my row, I know I'm going to add to it, right? So 2 times 1. So remember, row, column, plus 2 times 1. Now, because I've finished my row, I know that I've finished my element. So I've done the first row by the first column of the second matrix. And now I need to go over to complete this first row with every column of the second matrix. So this could go on and on and on, but you need to stay on your first row until you've multiplied by every column in the second matrix. So for the next part, I'm going to go 1 times 3. So 1 times 3. And then I'm not finished the row yet, so I know I'm going to have to add 2 times 2. 2 times 2. Right? Now I've finished this row with every column in my second matrix. So I know that I've now completed the first row in my result, right? So I move on to the second row of my first matrix and I repeat the same process. So 4 times 4, 4 times 4 plus, because I'm not finished yet, so I know I'm going to have to add, so 3 times 1 plus 3 times 1. And then I've finished that second row with the first column, so I do it again. So this second row with the second column. So 4 times 3. And then plus 3 times 2. 3 times 2. And then if I put that all together. All right, so I've calculated 4 times 1 plus 2 times 1, which is 6. 1 plus, I'll just get my pointer. So 1 times 3 plus the 2 times 2, 7. 4 times 4 plus 3 times 1 is 19, and 4 times 3 times 3 times 2 plus 3 times 2 is 18. So that is how I do that one. So multiplying by hand, with your first matrix, you need to multiply each element position in your first row by the corresponding positions in the columns of your second matrix. So you would do your first row with every column of your second matrix until there's no more columns left, and that would be elements across the top, right? And then once you've exhausted that first row with every column in your second matrix, you would move on to your second row of your first matrix and repeat the same process. You will notice when you've got really big by hand multiplications that these numbers are the same. So you're 4, 4, 1, 1, 3, 3, 2, 2, right? And remember, you can always check using your CAS. I'll just grab a screen grab. Right, so this is the calculator here that I've put in those two matrices, times them together, and it's come out with the outcome. So most of the times, if you're just getting the solution, you can just pop it straight in your calculator and get your answer. However, sometimes in some exams, they'll give you the answer and they'll be like, explain the calculations to get the element in the position 2, 2, or the element 18 in the result matrix. So you would have to say what was multiplied together to get that answer. So you do need to know how to do things by hand. But if you ever do get stuck, you can always use your calculator and use your answer with the preceding questions. I think that is all I have for that one. Also, whenever you're doing something on your CAS as well, how we looked up before, how to work out if the product exists. When you do something on your Casio that doesn't exist, so if you're trying to multiply a matrix that to another matrix and the product doesn't exist because the number of columns in the first matrix doesn't match the number of rows in the second, it will come up as no solution or error or something like that. So you won't be able to, that should give you an idea that product doesn't exist. So have a feel around with your calculator and try and get into some multiplication by hand. And yeah, that should be enough to get you started on that part of the chapter.